Special thanks to BI. So our Pixel sessions were $10 a session, and through the sponsorship of BI, they have very willingly and said that they were going to cover half of the expense for each participant. So thank you, BI, for covering those expenses. If you know a BI rep, make sure that you reach out to them and thank them for the support. Also, special thanks to FCS Financial for their contribution for our Pixels session, as well as our Pearl session coming up. Big supporters. So again, reach out to them and let them know that you know that they supported this. So tonight's session is with Dr. Allison Meyer. She's going to be talking about feeding and managing pregnant beef cows and heifers for calf success. So setting them up for the calf before the calf is even present, while the calf is in gestation or in utero, setting them up for on-ground success coming up. So Allison, Dr. Allison Meyer, I think the next slide was her bio.
I can swap it over. Do you want to do a quick introduction with our slides?
Whatever makes you happy.
Since the slides are already gone, Allison, I'll let you just take over with your bio. How about that?
Sounds good. So first, let me move. I have not had to do this on Zoom for a second either, so I've got stuff everywhere. So my name's Allison Meyer. I'm a faculty member at Mizzou in Animal Sciences, and I have a research and teaching appointment. My focus is obviously on beef cows, and I have been here for about 12 years. I did one of my degrees, my master's degree here, so I feel like Columbia is kind of, and Missouri are kind of my second home. I grew up in Indiana on a purebred cow-calf operation before starting in on this. So I think with that, unless do you have anything else, or want me just to get started? I'm seeing nods. Perfect. So I will say, if somebody has a question, I am trying to keep an eye on my other screen where the people are, but I'm not always great at doing that. So you can just unmute and interrupt me.
So what I'm going to talk, kind of keep an eye on that for you. So
perfect. Thank you so much, Heather. So as Heather said, my real focus here is to talk about how we can manage, the cow to set her calf up for success. I think that certainly, I know, especially when this is eventually online, anyone will listen to it, but I know that as women, many times we end up taking care of calves and being the ones who are worried about calves. I know that was often something that my mom still is the one that calls me about a problem calf, because she always wants to keep it alive. And, something that I always try to think about is not only can we manage this calf, but we certainly can manage its mother, while she's pregnant, to try to give it the best possible chance that we can. So first, just to get in a little bit to why it matters so much that we think about, saving calves. We do have quite a bit of calf death loss that is reported. About 6% calf death loss pre-weaning is reported nationally. And I'll say that I think this is really under reported, because if you look into the Missouri numbers from a similar time are also about 6%, but it only says that 50 to 60% of cow-calf producers in Missouri report dead calves. And I struggle to believe that, because it's pretty difficult to have very many calving events without at some point losing a calf in a year. So if we think about why this happens, about 90% of it isn't due to predators. And so that's really what I tend to focus more on. And as we think about the different things that really make up the reasoning that non-predator death loss occurs, some of them certainly are calving related. About 20% is what's reported, about, 15, 20% weather related. But a lot of the others are more in terms of respiratory disease, digestive problems, or certainly things that we may be able to help get the calf off to a little bit better start. So as we think about when this occurs, something else that I know some people have probably heard me say 1,000 times, about 2/3 of the calf death loss pre-weaning actually occurs in the first 3 weeks of life. So about 1/3 of it occurs within the first day of life. Certainly a lot of that is probably due to dystocia or difficult calving, or potentially, weather-related problems such as especially cold stress, or sometimes even, starvation can occur that quickly. And that next third, that's really more where we're getting into some early ramifications of failure of passive transfer or not getting enough colostrum, or certainly there we get into more starvation sorts of deaths, dehydration, things like that. So again, all things in this early time period that we can hopefully prevent. Now, if we can get this young calf, to survive that first 3 weeks, really it has a pretty good shot as we consider going forward. And one thing I meant to say here on this last slide, just to give some context, I know that when I show these numbers to feedlot people, and I talk about 6% death loss pre-weaning, I often have men's eyes get really big and they say, I can't believe you're okay with that much death loss. And I say, actually, it's probably closer to 8 to 10%. And they say, oh my God, if we had 8 to 10% of our calves die in a lot, we would, we're having a crisis. And so I do think it's worth noting that we have a lot of losses that are occurring, certainly that we maybe can't fix. If it's a genetic anomaly or something like that, we certainly can't completely fix that. However, the fixable portion is definitely costing us money. And right now, calves are worth a lot of money, even the first day of their life. And so it's really worth considering this, I think, a little bit more. All right, so now I'm going to move on to the crux of this. So as we think about it, this cow is the factory. Our goal is to keep the factory around. We want her to keep making calves. And, a calf, although it is worth money at day one, in general, most producers aren't really considering it being a successful calving season unless they've weaned calves. And so we want to get it to weaning, and maybe we want it to be replacement heifers, or we want it to be a bull, or we want it to, go into our feedlot, or we want to take it to the sale barn that day and we want to get a nice check. Whatever we want to do, we know in order to get it from here to there, we're understanding more and more that we actually really need to think about what's going on with the cow while she's pregnant, as well as what's going on with the cow and how she's getting nutrients to her calf when it's really young. So what my lab really has focused on, even before I had a lab when I was a baby grad student, I spent most of my time thinking about fetal programming or developmental programming. And that's really how everything that happens to the cow or the mother affects their offspring long term. And so, most people think about it in terms of how is the fetal environment or how is pregnancy influencing the calf early in life and then later in life. But I really like to think of it also as how is the calf's early life influencing the calf later. Now, we know that the cow influences the calf quite a bit in its early life, but really it's all just a big spider web. And we know that in order to have calves do really well their whole lives, we need to manage the cow well. So I personally focus mostly on calves up to weaning, and that's partially because I think that matters to all cow-calf producers. Certainly there are people who mostly think about, fertility or mostly think about carcass effects. We do some of that, but in particular, we know that all producers need calves to survive and grow to weaning. And so that's what we focus on. As we think about this, my take is always, how is that calf changing from the time it was conceived until the time it was weaned? And so this just shows you some of the developmental windows that occur in this time. My lab really focuses here on what's in gold, and that is for a couple of different reasons. The first thing is we really focus here in late pregnancy rather than mid and early pregnancy, because that's when most of the fetal growth is occurring. So there's all kinds of different stats, but usually we're thinking that well over 50%. So usually it's like 60 to 70%, depending on what you look at, of fetal growth is occurring in the last third of pregnancy. In addition to that, of course, a lot of organs and tissues are really rapidly growing, and they're developing, and they're getting ready for the outside world. But, it doesn't take that much of a change to really affect this fetal growth at this time. Now, one thing I want to mention here, and I apologize, some of you have heard me say this so many times, you can probably give these few slides, but I think it's important to consider why we don't want to decrease birth weight nutritionally. So what I'm showing here is, a guess at what fetal weight looks like for a calf from conception all the way until calving. This one is showing it about 280. And so if this is what it should look like, that's what the calf's genetics tell it that it should be. So let's say that, it wants to be 80 pounds at birth. If something changes and it isn't able to grow to that 80 pounds at birth, let's say it only can get to 70 or maybe 65 pounds at birth, we've changed its growth trajectory. We've changed it from what it wanted to be genetically. Now, some people may say, hey, that's a good thing because that calf should have an easier time at calving. It should come out pretty easily. The problem is that it wanted to be bigger. And so because it wanted to be bigger, it could very easily have poor fetal development. It could be less mature at birth. It could be less vigorous, weaker. In particular, smaller calves are not a good thing when it's really cold, but they also generally have less brown fat and some of the things that are trying to keep them warm. And so they can be less cold tolerant as well. So one of my biggest soapboxes is I have no problem with wanting to decrease birth weight to decrease dystocia, but you do that by changing genetics, not nutrition. So if calves are too big at birth, the goal should be to try to select more calving ease bulls, to try to remove cows from the herd that consistently have really big calves, not to starve birth weight out of calves. That's a really bad thing. Unfortunately, there still are a lot of older generation folks, including some vets, who talk about how you don't want to feed your cows too much in late gestation because you'll make calves too big. And there's actually no data to show that you can feed too much birth weight into a calf that it doesn't already have the genetic potential for. So really, it can only get as big as its genetics allow it to be. And again, there's a lot of really negative things that can come with not being as big as it wanted to be. We don't like it when we hear that people have really small babies, right? We don't like it when we hear that someone had a 5-pound baby because we know that it probably has some issues. So calves are very much the same way. So now as we think about the other big reason that I'll talk about a lot more here that our lab focuses in late gestation is as fetal growth is really increasing, of course, the nutrients that the cow needs to put to the fetus, so that she's sending to her uterus so that her fetus gets enough nutrients, that really increases too. The problem with that is when we really think about, how we choose calving seasons, we usually choose calving seasons in the U.S. to try to make sure that when cows are lactating, when they're, making milk, have their calf aside, and we're trying to get them rebred, that's when they have the best and the most forage available. So that often means that they're in late pregnancy at a time when there isn't much forage available. So if we think about spring calving cows, let's say a March calving cow, she's in late pregnancy in the winter. Or if we think about a September calving cow, those falls are actually pregnant in the summer when it's really common that we have drought. Of course, we don't in most parts of the state this year, but also that we certainly can have heat stress and fescue toxicosis. So these are some of the many ways, essentially, that we can mess up nutrition during late pregnancy. And really the two most common are up here at the top in just not having enough forage or having poor forage quality. A lot of the hay that we feed here in the state is lower quality just based on when we have to bale it around weather. The other big reason that I always joke, you can't be a cow without being a heifer first. So the first parity or the first pregnancy is always a challenge, and it's a challenge partially nutritionally, but partially for other reasons we don't totally understand. And so really the first calf of every female always is at some disadvantage, which I'll show you a little bit more later. And again, that's something that happens to everyone. Fall calvers experience heat, spring calvers experience cold, And certainly in this state, any fall calvers that we have are often experiencing fescue toxicosis as well. So the first thing I'm going to talk about here as far as our research is a study that a couple of studies that we completed a few years ago, where really our big focus was to try to determine how late pregnancy nutrient restriction, poor nutrition, really trying to mimic, a drought situation or really poor quality forage, how that really affects everything from the pregnant female to the calf at weaning, and really asking the question in terms of all of these windows. So the sorts of things we were really focused on here was how is essentially the nutrients that are getting to the calf through the uterus and the placenta, how is that affected in late pregnancy? Then right around birth, we especially really focused on the neonatal calf, and so things like how vigorous was it, its metabolism, things like that. And then later more into its growth pre-weaning, as well as milk yield of the dam and how that affected it. So I'll give you just a little bit of background on each of these types of studies for those that are interested. Essentially how we did this, and we did it in 2 different experiments. This was a very COVID era set of experiments. Essentially we had heifers in one experiment that were from a single sire, in another experiment that were from a very limited number of sires. They were from one herd, fall calving, and they were bred to a single sire in each experiment. They were managed essentially to meet or exceed their requirements, their nutrient requirements, until about day 160 of gestation. So for the last essentially 4 months, so for the last 120 days, we fed them one of 2 diets. So we either fed them a control diet, which I'm going to show in gray, and that was to meet all of their protein and energy needs for their own growth, because they were still growing as heifers, pregnancy, maintaining their body condition, or 70% of that, which I'll show in gold. And so that was 70% of what the total energy and protein requirements are. How we did this is we fed it in what's called a Kaelin gate system. So here you see this cow, she's kind of put her head through this gate. It's through this area where there's the green. And she has this little, we call it a necklace, but essentially on a cord around her neck, she has a key that can only get into a specific gate. So they learn how to use these really quickly, and they can only get in to eat out of the one gate, which means that we can control what we put into the gate so that is what the cow can get. And so essentially we fed them a poor quality forage that was supplemented, and we're able to really fine tune their nutrient intake. At calving, we kept them in this same area because we didn't want the calves to be able to get to anything really but milk. And so we went ahead and fed all of them to meet their energy and protein requirements. So we were trying to feed all of them the way we should. And essentially we kept them in that same barn until about day 150 of age for the calf. And then after that, we fed them as a single group in some larger dry lot pens. So big picture, this is kind of how their nutrient intake looked. This is showing energy, but protein would look the same. And so you just see that they're, about 70% different for late pregnancy, and then they came together in lactation. So we did this in 2 different years. In one of the years, we raised the calves for 48 hours, and then we actually slaughtered them and took a bunch of tissues. And that's the data that I have right here. In the other one, we kept them throughout weaning, like I showed you back here. And I'll show you those data a lot, because when you keep calves alive, you can get a lot of really cool data. So big picture, we expected nutrient restriction or poor nutrition during late pregnancy to decrease birth weight. And it did in the second experiment. In experiment 2, it decreased birth weight by about 15%. And that was generally what we expected. Most of the tissues in the calf were decreased, but they actually spared their brain, which is really common. So in a lot of, human and biomedical models, all the way down to livestock, we know that fetuses that aren't getting enough nutrients really try to shift the nutrients towards their brain to try to keep that brain development going. We also found that the one bone that we collected weights on, the femur, was similar, as well as lungs. Now, in the other experiment, so experiment 1, we actually found that the dams, the pregnant heifers, completely maintained fetal growth at their own expense. So first I'll walk you through what's over here on the left-hand portion of the screen. So again, controls are in gray and nutrient restricted are in gold. So here you see the body weights of the heifers throughout the end of pregnancy here, and they're increasing for the controls. They're increasing because they're pregnant, so they're gaining, weight of pregnancy, but also they're growing. And so you see here post-calving, they weigh a little more than they started. And these girls read the protocol and they gained almost exactly what we thought they were going to. So the controls did exactly what they should. Their nutrient restricted heifers, on the other hand, really were a flat line. And so as their fetus and their uterus was getting bigger, they were losing weight. So you see that they weighed about 130 pounds less here post-calving than the controls. And also they had lost their own weight. So they should have been gaining, they should have been growing, but instead they actually were smaller because they had lost condition and they had also lost some muscle. So body condition is what you see in this bottom figure. Again, the controls really stayed at about a 5.5, which is about where they started. That's where they were at calving. The nutrient-restricted heifers, on the other hand, they lost condition really throughout pregnancy, and they calved it closer to a 3.5. So there was about a 2 body condition score difference here. So despite this, which is actually almost exactly what the experiment from this data set looked like, actually these calves were all pretty much the same size. They had some variation within themselves, but between the 2 treatments, they were not different. We don't just weigh calves. We actually measure them about every way that you can measure them without cutting them up. And so you see every line that's on here, we measured, and they were all similar for these treatments. We also do a ribeye area on these baby calves, and they were similar as well. So big picture is that, some groups of animals certainly are going to maintain their fetal growth, and some of them aren't. This is about what we see across old data sets, new data sets, that about half of the experiments we get a birth weight change and half of them we don't. Now, these calves, even though they were the same size, they definitely were not the same animals. So I'm going to show you a lot more data from them and from their dams just to give you some idea of that. So their gestation length wasn't different. We allocated them by fetal sex, and so there was a similar percent bull calves across these. But the calves that were born to the poor nutrition dams, they actually were more likely to have an abnormal presentation. So by abnormal presentation, I mean that either they came back feet first or they came with one front leg back. And although we didn't have a lot of N, I apologize. You're going to hear my dog bark at the cat because, they know I'm on Zoom. Although we didn't have a lot of N for this hasn't been reported a lot, partially because most people who are doing this sort of work don't necessarily pay quite as much attention to cows at calving as we do. But there's an old data set from back in the 70s that shows something really similar. And what they believe is going on, or believed then was going on, is either that the uterus in the thin cows or heifers was actually weaker, and so they couldn't help get the fetus to the right position, or that the fetuses were weaker, and so they couldn't actually right themselves to get to the right position. What you see from this is we essentially pulled a calf whenever we saw that the cow was struggling, or we saw that it was the wrong presentation. We went ahead and pulled it, and so we were able to get them out pretty similarly. This delivery duration is time from the first site of a foot until birth. So as we think about that idea that maybe the fetuses were a little bit weaker, what we found is that calves that were born to nutrient-restricted heifers actually took longer to attempt to stand and to stand. And so we take this to mean that they weren't as vigorous. So if we think about, what we mean when we say is a calf vigorous, what we really mean is, can it do the things a calf should do right after birth? And it's pretty difficult to measure that. A lot of breed associations and some research papers will say things like, give it a vigor score, where, 1 equals dead, 2 equals really weak, and 3 or 4 or 5 equals very vigorous. It's kind of hard to really make that mean anything, because what you define as very weak and I define as very weak can often be really different. In fact, there's only one good definition in that one, and it's dead, because it's hard to argue with that. So what we do is we take an amount of time to these things that calves normally do, and we figure out how long it takes for them to get to a sternal position. So essentially where they're laying kind of like a dog, how long it takes for them to attempt to stand, and then how long it takes for them to stand successfully for 5 seconds, not 10 minutes, 5 seconds. So what you see here is that, we didn't have any difference in how long it took them to get to sternal, but again, it took the calves born to those thin heifers longer to attempt to stand and stand. I'll mention these are fall-born calves, and so it was warm. They were mostly born in, late August to October, and so it was not cold stress that they were combating. And so I think if these had been spring-born calves and they were dealing with cold stress, certainly this vigor difference would have been even bigger. So the other big thing that we are really focusing on that has been challenging throughout time to measure is colostrum. And so what we do is we take one of the rear quarters and we take the entire volume, we strip it out by hand before the calf ever has suckled or has nursed any colostrum. What we found is that is a really good indicator of the total amount of colostrum in the female, but it also means that we leave 3/4 for the calves. And so the calf can, nurse those 3/4, do all of its normal things. And so we're not completely interrupting that. But we get a really good measure, which you don't get if you're just taking a strip sample. So what we found in this study was that poor nutrition during late pregnancy decreased colostrum yield by about 40%. That's what we found in the other one as well. And so we think that's a pretty, at least consistent number in our model here. What we found with this is that nutrient restriction actually was primarily decreasing lactose, which is the sugar that's in milk. And that's really important for calves to get an energy source, a quick energy source when they're low on glucose and they, really need a good shot of energy. On the other hand, we found that it had similar total fat and similar total protein. Now, when it comes to immunoglobulins or, those antibodies that are in colostrum that are providing passive transfer that we get so worried about, interestingly, these nutrient-restricted heifers had more IgG from a concentration standpoint. So essentially, it was just like super concentrated colostrum, which allowed those calves to get a similar total amount of the IG. That actually meant that calves that were born to these heifers that got nutrient restricted actually looked like they had, or they did have greater 48-hour serum IgG, and this is generally considered to be an indicator of passive transfer. Big picture, both sets of calves achieved strong passive transfer. We actually had almost no health problems in these whatsoever. We had one that died from a congenital kidney defect, and we managed to keep her alive way longer than we should have. But really, we had a very healthy set of calves here. Interesting thing to point out, though, and I'll come back to this a little bit later as well. In this data set, what it really shows us is that, calves are probably not as negatively affected by passive transfer or the ability to achieve passive transfer as they are groceries or having enough nutrients. And that's something that comes up again and again in our data sets with colostrum. So I just told you we had really healthy calves, and so I can't really show you much in the way of calf health data from our study. So I'll just show this older study from the University of Wyoming. So big picture, these green bars are heifers that got high nutrition. What really happened is all of them had pretty bad nutrition for about 60 days, and then 30 or 45 days before calving started, they started either feeding them better or not feeding them better. And so the low nutrition is what's here in gold. They're the ones that just had poor nutrition throughout late pregnancy. Big picture, what they found is that more of those calves died at birth or right there around birth. So you see that they'd already lost about 10% of the calves whose dams were on the low nutrition treatment. And then by weaning, there were about 75% of those calves left. And so they had quite a bit of death loss there from birth to weaning, and it was really only seen in this low nutrition group. The reason I love to show this data set is that the reason that they give in this paper is they had a scour storm. So they did have a high incidence of scours in these calves. And what they found is that although, both treatments had some scours, they had a lot more death loss in these calves who were born to the dams with poor nutrition. So it gives a good example of how maybe you think everything's fine and then something bad happens, and that's when you actually see a difference. Whereas in our study, we just didn't have a scour storm. Calves were pretty healthy, and so that may be why we didn't really see health issues. So now as I move into milk yield, what we do is we take 4-hour milk yields. And so essentially what that means is we remove the calf from the cow for 4 hours. We first empty the udder completely, and then 4 hours later, we empty it again with a mechanical milker. So if you wanted to figure out how much she actually made for 24 hours, you just multiply this by 6. I should probably replace this figure with that. But as you can see, really from 21 days of lactation all the way out to about 150, if those females were nutrient restricted in late pregnancy only, so that's not true during lactation, at calving we were feeding them all the same, then they made 15% less milk. So there was a really long-term effect of that late gestation nutrition on milk yield. This may be because they were heifers. I don't think it is. And so we're actually nutrient restricting a group of cows right now. So we're running a very similar experiment just in mature cows. And so in about 6 months, I can tell you, maybe 9, I guess, to get through lactation, I can tell you if the same thing's happening in mature cows. Now, I told you these are the calves that were born with similar birth weights, so they didn't have any differences in birth weights. But probably mostly because here of the milk yield difference, we see that at about day 150 when we moved them out of that barn with the individual intake facility. At that point, the calves whose dams were nutrient restricted weighed 15% less. And then about 90 days later, when we weaned them at day 242, they weighed about 13% less. So you see that quickly we saw a body weight difference here in these calves. In fact, only by about a month and a half of age, they were different. Now, I told you before we measured them about every way you could. And if you look at those measures, we already saw differences in their girth or how big they were around at all 3 of these locations already at day 21. We also saw some skeletal growth differences already by 2 months of age. So they were shorter. They were shorter bodied, so they weren't as long. They had shorter bones, smaller diameter bones. And so, we definitely were affecting the growth of these calves. Ribeye area was only actually different at a couple of time points in here, but from a statistical standpoint, but I believe that it really was the whole time, and it was just a little bit of higher variability in getting good images on these. So I won't talk about it a lot, but I think it's useful to consider what's happening post-weaning, because I told you that really at weaning there was a lot less calf, right? 13% less body weight in these calves. And I believe in many production systems, there also would have been a little more death loss in these calves born to the dams with poor nutrition in late pregnancy. So what we did is we kept these around here at the beef farm post-weaning. And so if you just focus on the last few things over here on the calf column here on the right, we did have similar carcass weight and quality grade, but we had essentially leaner or lower yield grade carcasses in the calves born to nutrient restricted dams. So eventually they caught up from a growth standpoint, but they seem to kind of be at a little bit of an earlier point on the growth curve. They hadn't deposited quite as much fat. Now, we do have feed intake data from the feedlot. We have not analyzed it yet because it's kind of a bear, but it will be interesting to see if those calves were more or less efficient, because really both are possible. So again, this is kind of an overall big picture of everything that we learned from that study, or most of the things we learned from that study, in case you want to take a little closer look at that. But what I'm going to do now is I'm going to shift gears a little bit and think outside of nutrition, or in more real world nutrition, not just, me experimentally kind of inducing a drought-like scenario. What are all the things that affect calf survival, and what do we know about things that happen normally? So as I think about what affects calf survival, especially in that young calf, that newborn calf, I really think mostly about these big four items. So we already talked some about calving difficulty, and maternal behavior is what I mean here by behavior, colostrum, yield and quality, the vigor of the calf, and then also its metabolism. So does it have enough nutrients, and is it doing the right thing with those nutrients? So what I'm going to do is I'm going to walk you quickly through a few different models that are a little more real world. I think that help explain what's going on. So recently I went back into our big database of calf data that we've accumulated here, and asked the question of if we put cows and heifers right around calving into two essentially categories based on their body condition score, how does that affect their calf? So what we did is we had about 250 total cows in this data set. And we just split them into if they had a body condition score less than 5 on a 1 to 9 scale. And so I used 5 as thinking that 5 is kind of the lower end of a recommendation I would give for calving. I prefer to tell people to calve at 5.5, but 5 is relatively common. So these cows were averaging about a 4.5, so they weren't incredibly thin. This wasn't from our planned nutrient restriction studies. These were really just from a set of experiments in which we were collecting data from cows at calving. Sometimes my lab was managing them pre-calving. Sometimes the farm staff were managing them pre-calving. So this was really just the ones that, happened to be thinner for whatever reason. On the other hand, we then essentially made a category for cows that were 5 to 6.5 body condition score. And so you see they averaged about 5.5. Then again, these were all fall calving. So we, in this case, don't need to consider differences between, cold and heat stress. So as I'll go through this pretty quickly because it's pretty easy to, I think, kind of understand these treatments. We found that in the thin cows, we had 12% smaller placentas. So we collect placentas after expulsion. It's one of the more fun but challenging aspects of what we do. And we found that placenta size was smaller in these thin cows. We found that before as well. And that generally means we're going to have smaller calf birth weight. That's what we observed. So it was less, not quite as big of a difference as the placenta. You see about a 5% decrease in birth weight. I'll say that part of that's probably we have a wide variation in birth weights in this herd and in most beef cow herds. But also I think that because these are fall-borns, there is, I believe, what I call a clamp of heat stress that actually, birth weight is already reduced some by heat stress. And so that may have kind of lessened this effect. I'll show you some calving season data here in a little bit. So we didn't actually get a vigor difference in this data set. I suspected we would. I thought that the thin, and sorry, I've got these colors opposite on this one. They should be gold over here for thin. I thought that we would see a difference, but, a couple of things to note. One is that these, again, were fall-borns, and so most of them were not cold at all. Another is that there's a ton of variation here. So, some of these are less than, they're 5-ish minutes that it takes them to get to stand. Some of these are up at, almost an hour and a half. And I will say that if a fall-born calf does not have its act together by an hour and a half, I often intervene. I usually give it 2 hours in the spring. And that's mostly because, well, at 2 a.m, I'd like to get the show on the road. But also sometimes you can tell that like it could be they have tight tendons or the cow's being difficult or it's really muddy in that spot or something's going on. And so we go ahead and intervene. But big picture, we didn't have a vigor difference in this one in the falls. We did find a really similar decrease in colostrum yield. So here you see that the thin cows had single quarter colostrum yield that was about 44% less than the adequates. And again, that looks really similar to our planned nutrient restriction experiment, which was 35% in one and 40% in the other. Now, as we think about what was going on with this colostrum, in this case, we found that even though the thin cows had a little more concentrated immunoglobulins, they still had less overall immunoglobulins than the adequate cows. And that's pretty much what nutrients looked like as well. So essentially, if you were a calf born to a thin cow, you had less colostrum and all the good stuff in it. So it then wasn't surprising to us that essentially being born to a thin cow meant that you were in worse shape metabolically. So glucose is what's over here on the left, and then triglycerides, which are essentially the fat that's coming from the colostrum, is over here on the right. And if you just take a look at the gold line, you see that, calves born to these thin cows had less glucose really from 6 hours to 48 hours of life, had less fat from 12 to 48 hours of life. So at this point, calves having less glucose, less triglycerides really means that they didn't get to eat as much. So they had less groceries. Metabolically, that's not a terrible thing probably for these falls because they weren't cold. But again, had they been born when it was cold, not having these energy sources is a real problem for them. And I'll tell you that the controls here, or the adequates, the black line, looks more like our normal animals across our larger data sets. So transitioning from that, another one that we've been studying quite a bit over the last decade plus, I guess, is the question of how spring-born calves are different from fall-born calves. So essentially to answer these questions, what we did is we combined 4 different calving season data sets from the spring. So you see which years they are here, and then 4 from the fall. So we didn't include some of the newer data that we included in that last one because the graduate student that did this finished in 21 and it's already published. But you see we've got about 400 calves total in this, and you see what our spring and our fall calving seasons are. So one of the big things we wanted to ask the question of again was how is birth weight and calf vigor affected by calving season? In general, we know that fall-born calves are usually smaller, but there's not a lot of data sets that really are asking a lot of other questions just because it's challenging to do. And in a lot of parts of the country where people do work like this, it doesn't make sense to have falls, or doesn't make sense to have springs. So I was trying to take advantage of the fact that we have both calving seasons. So again, as you see here, fall-born calves did weigh less at birth. Not a massive difference here. It's only about, I think, 5% again. But they did, or maybe 8%, but they did weigh a little less at birth as we expected. And then they also were a little faster to stand. So definitely I expected that just from watching with my eyes. Again, we've cut off some of the the tail enders here of the spring, because usually a calf that doesn't stand up at 2 hours in the spring is cold and it needs to be warmed up. But definitely it takes spring-born calves a little longer to stand. I'm actually surprised this difference wasn't a little greater, and I think it probably was our management kind of affecting that. So some other things that we could answer with this was what's really going on with the metabolism of a baby calf. So part of that question is what's happening with rectal temperature. So as expected, these 0-hour calves, essentially what that means is it's after they stood, but it's before they ever got colostrum. and we try not to mess with them at all before they stand unless we have to. And so you see that they actually were colder. So this is in degrees Celsius, but I think they were about a degree and a half or 2 degrees cooler from a rectal temp standpoint. Not surprising. They come back together after they consume colostrum and their metabolism's really going, and then they separate again at a day and 2 days of age. So if you think about that, calves born when it's cold, of course, are going to be cooler. Their bodies are trying to warm themselves up. And so what ends up happening is if they don't have enough nutrients to use as fuel, then they start to kind of catabolize themselves. Now, baby calves don't have much fat compared to some species, but what we find pretty consistently is that calves born when it's cold, they start to mobilize the fat they have. So these NEFAs, non-esterified fatty acids, really are an indicator of trying to move out the fat that you've stored so that you can use it metabolically. The thing with calves is if they use this much early, they just don't have a lot more to take. And so we often find that doesn't last too much past 12 hours of age, but you see they're different here. Some other big things that we observed is that fall-born calves have less stress indicators. I think that might be because they're smaller, and so their births are a little easier, but also probably a fair bit of that has to do with cold, and some of the stress indicators I think are probably kind of popping up due to spring-born calves being cold. On the other hand, fall-born calves have a lot of dehydration markers, so their electrolytes are kind of out of whack, and they've got some other things going on in their blood that really probably just suggests that they're pretty dehydrated. I think we probably need to make sure they have more access to water, but in the real world, that isn't something that's always true for a newborn calf. So the last model I'm going to talk about here a little bit is dam parity. And so essentially what we've done in a couple of different studies, if we've asked ourselves, how do cows or how do multiparous, cows, so cows that in this case were on their third or more calf, how do they compare to heifers? First parity, primiparous dams. And so we did this in spring of 17 and fall of 18. So we had one spring, one fall. And big picture, how we've handled it is we managed them together in late gestation. They calved together, and they had calves that were born either from the same sire or a small group of sires. So big picture, heifers have way less colostrum. And if you take a look at the numbers here, heifers have like 25 or 30% of the colostrum of mature cows. And in this study, this was heifers versus, 4 and 5 year old cows is what we were using in this one. And so it wasn't even necessarily, your kind of prime 8-year-old cow. As we think about what's different about that colostrum, big picture, they made less nutrients, in particular, less of that milk sugar, and then also less fat. And so really, the calves born to heifers were getting way less nutrients they could use as energy. Now, these were fall born, so they weren't super cold. But again, if they had been born in the spring, I would have been worried about those calves metabolically. On the other hand, actually there's, again, concentration of immunoglobulins or those antibodies in colostrum in the colostrum of heifers. And we found that statistically they had similar total IgG. And again, that really we didn't have a difference in this study in 48-hour serum IgG as an indicator of calf passive transfer. If we look across our bigger data sets, we do generally find that we get some difference in calves born to heifers versus cows, but that's a little bit of a different story for a different day. So last little bit I'll show you about that. We've talked about some of the other things that we can see in calves. We found that in one study, we didn't have a difference in time to stand for calves, whether they were born to heifers or cows. In the other one, it took calves born to heifers longer to stand. I already showed you the colostrum yield. And then if we look at them metabolically, some of the things I talked about that were bad, so having lower glucose in your blood, and then having more NEFAs, so more mobilization of your own fat, are bad. Those are definitely things we observe in calves born to heifers. So big picture, some of the most, stressed calves are the ones that are born to heifers. And I am a firstborn daughter, so I will say that I find that those differences really, really interesting. So if we also look at some other stress indicators, I started to kind of allude to these before about some of the spring-born calves, but the things you see in the gold box here are pretty common indicators of stress from a blood chemistry standpoint. In general, these are things that are also affected by dystocia or difficult calving. And what we have found is we see this pattern if calves are born in the spring. We see this pattern if calves are born to dams who have poor nutrition during late pregnancy. And we also see this pattern if calves are born to heifers. So important to note, all three of those, show calf stress indicators. But also, what I think about is if you have a calf born to a thin heifer when it's cold, pretty much that calf is in the worst shape it can be early in life. And so if it's metabolically stressed, its tissues are stressed, it's going to have a harder time actually achieving passive transfer. It's going to have a harder time staying warm. It's going to have a harder time staying healthy and making it through those first few weeks. So that leads me into kind of some take-home messages, and I've got these split essentially between what are things we can do with pregnant cows and heifers and what are things we can do with calves. So biggest first thing that I try to say in every talk I ever give is know your forage resources. So if you have harvested forage, if you have hay or if you have silage, it's really important to, do a hay test, do a forage analysis. It's not very expensive in comparison to something like a genetic test. It really affects a lot of animals. And so if you're going to feed something that is stable, please have it tested and understand if you need to supplement, or if you've got, hay that doesn't need supplementation going forward. So then the next point, certainly there's not a one size fits all, but our real goal here is to maintain body condition of pregnant cows and heifers. And I'm saying maintain if you're already at a 5 to 5.5. If your cows are weaned, or if calves are weaned from your cows and their condition score of 4, they don't need to maintain, they need to gain condition. But, the big picture is we really need to supplement protein and energy when it's necessary to get the body condition score to what we want it to be at calving. We know we already are really in trouble if our cows calve at a thin body condition, because we're gonna have a harder time getting them rebred. But I've also shown you a bunch of data to say that also means that their calves are in a worse place as well. So if she doesn't raise a calf because her calf dies, or her calf is really small, it's unthrifty, and she's not pregnant, then that's an even bigger strain on the system, certainly for that cow. Also, heifers really aren't cows. Heifers need to be treated differently. One of my big pet peeves is if you have a large enough herd, split pregnant heifers from pregnant cows, because those heifers are smaller, they can't compete. They also still need to be growing. And if they start out their first year calving at a low condition score, you're really in trouble. And then also consider cold stress, heat stress, fescue toxicosis. Cold stress means animals need more nutrients, especially more energy. Heat stress means they're going to eat less. And fescue toxicosis is just a whole nother ball game that certainly makes heat stress a lot more challenging. But in particular, think about these in terms of the pregnant animals, and can you alleviate some of that from the pregnant animals? From a calf standpoint, as we think about making choices to give them the best chance of survival, certainly the easiest thing or at least less labor intensive during calving season, is to, manage their dams so that the calves are ready to go, and to choose a calving season that makes sense for your environment as well as your facilities. When it comes to shelter, the spring and fall data would suggest, calves, and I'll tell you, those are not bad conditions that we have spring and fall calves in. Many people would kill for those calving pens, but calves that are cold are in a worse place metabolically. So is there a way to provide a windbreak for those calves if they're born when it's cold? On the other hand, newborn calves need shade. I didn't show you how broken their rectal temperatures are after 2 days of age, but their thermostats are kind of broken. And so they really need access to some shade if they're born in the fall, which for many of us is actually late summer. As we think about colostrum management, I showed you a few different groups of animals who are likely to need some supplemental nutrients and colostrum and maybe even supplemental IgG if they're born to thin animals, if they're born to heifers. And I'll also tell you, I think that fall cows in general are making less colostrum. I just don't have the data to back it up yet. So something that I often encourage people to think about is consider how much money a calf is worth right now. It doesn't cost that much to buy a bag of colostrum supplement or colostrum replacer. I think many times our calves that have dams that are alive and we see them suckling, they don't even need colostrum replacer. They just need some colostrum supplement because what they really need is a boost, especially often at 12 hours, 24 hours, something like that. In general, what I always say is if a calf looks hungry, especially in the first day or two of age, up to even a week, if it looks and acts hungry and you can start to actually see it losing some condition and getting thin, it is hungry. And in particular, if it's born to a heifer, a thin cow, if it, had a difficult birth, if its dam was really heat stressed or if it was really heat stressed, those are ones that I think we really especially need to consider giving some more groceries, because if it comes out and it's alive, it's worth money. And we really need to try to keep it alive because it's the right thing to do. And from a financial standpoint, certainly we have a lot of reason to want to do that now. Probably talked a little too long, but I definitely want to acknowledge our funding sources. These are some of the people who've contributed a lot to these data. You might recognize Shelby Jenkins. She was one of my favorite undergrads when she was here previously. And then also feel free to reach out to me with any questions. Email is usually safer than my office phone because I don't sit at my desk that often, I won't lie. Especially right now, I'm at the farm an awful lot. But if we have any time for questions, I'm happy to answer them. Sorry I talked a little longer than I thought I would. And thanks for listening.
Thank you very much. That was awesome. So if you have a question for Dr. Meyer, please unmute yourself, turn your video on, and have those up and going while we're waiting for those questions to come in. Cory, if you want to go ahead and pop up our survey link since we're running close to that 8 o'clock mark, please fill out the survey. This really helps us. You can either visit that website or grab your phone right quick if you're not using your phone to view this and fill out the survey for tonight. Thank you again. You do such a great job at kind of, I don't want to say dumbing down, but like taking the research, right, world and the research words, verbiage down to a level, or to a level, I shouldn't say down, but to a level that is easily understood by a producer that is not in the research world, right? I mean, we don't have that research background necessarily. And so making it easily understood from that scientific world research to a level on the farm level, right? That we can understand. So again, if you have questions, please unmute and bring those up. I did have a couple of questions. So when you were talking about the ribeye area and the rib fat of the calves coming from a carcass ultrasound technician, right? Who is doing those measurements, and then how are they being interpreted? Because I know from ultrasound technician world, right? Labs, like we can't do our own interpreting of those images because of the third party verification ultrasound world, right? So how are those measurements being taken? And you did mention your concern about the variability and the reliability of getting those good images for those calf. So can you give a little bit of background about how those images are taken and measured?
For sure. So, I mean, one difference in terms of research is most labs who do this with research do not send it off. Most do it ourselves. And, you know, one of the questions always is, of course, we want to be as unbiased as possible. It's really difficult in these restriction studies, I won't lie, because if I feed them often, and right now, many days I feed cows, I know who's getting what. And I also see condition just coming off of them. Like I know, I see it. So it's pretty hard to blind it in this one. I will say that the calves, on the other hand, though, it is more difficult to tell. I mean, we remember numbers, ear tags, but it's much more difficult to tell. And so the method that we used came from some people at Ohio State. And what they did is they used essentially a swine or small ruminant probe on babies. And we did that up to, I'm trying to remember, we carcass ultrasounded at 42, 84, 126, and weaning, I think is what we ended up with. Or maybe, I don't know, somewhere. It was like 4 times pre-weaning. And so that worked for the first 2 or 3. And then we moved up to the cattle probe. Honestly, it was when we used the cattle probe, which really fit over their whole back, that the variability, it was a little bit it was worse. And I think we just probably didn't get quite as good a contact. Our approach with, we didn't do back fats on the calves. They honestly almost had none. But our approach with the ribeyes is that we save the images and then we go back and either one person traces 2 or 2 people each trace 1. And then, in fact, one year we did 2 people each tracing 2. And so we had 4 numbers that we could average. And so that part can be kind of blind because, you know, you're not seeing the animal. I'm not very blind when I'm doing a rump fat and I'm standing next to a thin cow. But, you know, you can be a lot more blinded to that. And so we also, when we're doing stuff like that, my preference is for 2 people to do something, because then if they're 10% off, like we can say, okay, both people go back and do it again. And we'll see if that kind of fixes it.
Using
in honesty,
the Aloka's measuring. So the ball to measure
So actually, what we're doing it on ImageJ on a computer then. So we're pulling it off. Yeah. Because that ball is miserable. Yeah. Absolutely miserable. So, you know, we have a stupid number of ultrasound images that we've saved from each of these. And I'm doing the eyes now, and I are saving the images anyway. And I usually do 1 or 2 extra, but we always, we do duplicates and everything we can. And then if we don't believe something, we'll do a triplicate. I think that helps. Really, statistically, I think these were all like between 0.1 and 0.15 or 0.2. And so I think that they really probably were different. But you know how scientists are. Sorry, that's very much, it's very in the weeds of how we do stuff. But yeah, I wasn't sure it would work. And actually it worked really well for those pre-weaning calves. So we're about to do it again and we'll see how it goes.
Any questions from anybody else? Okay, so when we talk about calf vigor, it kind of reminds me of, you know, when you talk about like, there's not really a rubric, right? Like dead is dead, obviously, but then getting, you know, this is the next scale, this is the next scale, this is the next scale. And going to producers' operations and doing the ultrasound, a lot of the other things that are going on while I'm ultrasounding includes docility scores, right? The cow. And so again, it's kind of an kind of a subjective measure, right? It's the producer saying, okay, this is a docile cow. This is not, you know. is there a way to kind of rubric that calf vigor numbers out so that it becomes more impactful or more meaningful of a measurement? And then also with that, calf vigor and cow docility, is there a correlation between the two?
So, yes, there definitely is a way to make it more useful. And we actually do vigor scores as well. So in this study, we had differences at 20 minutes. So for a little while, we did vigor scores at 2 minutes, 5 minutes, 10, and 20. 2 minutes is just too early. In fact, especially, it's somewhat shocking how many calves spend a minute with their feet barely in the cow before they're out. And so they kind of have a little bit of a head start. But anyway, when we do scores, what we have is we have a system, like a scoring system we adapted from some Scottish researchers that used it in sheep. And so ours are based on more like a real rubric where it's based on, have you achieved this? So a 1 means that they're laying out completely flat with their head down. A 2 means that their head is up, but they're still flat. A 3 means they're sternal. 4 means they've attempted to stand. And a 5 means they have stood. And so that's the kind of thing that is meaningful. Whereas literally there's a bunch of old papers that say where 1 equaled dead and 3 equaled very vigorous. And you're like, oh, okay, well, no wonder you found no differences. The other thing we found is that for vigor scores, they're only really useful if they're all at the same time. So they change so much that, if you're going to say, like, I wish breed associations and such would listen to me on things like this, but, if you're going to give a calf vigor score and it's not going to be immediately after birth, then it should probably be that it's all at least a day of age. But also you should try to look at them all in the same conditions, because if some of them are at a -20 and cold, and some of them are on a crisp, beautiful day when they're running around, a different story. So I think, that's kind of what it comes down to for everything. And I think most of the docility, temperament, behavior sorts of things, they are trying to put it more at that, like, what were the actions they were doing. The reason I get from a lot of people, they say, oh, I use this vigor score and, oh, we did it whatever age we found them. Well, it's because it's hard. And it is hard. I mean, we don't sleep during calving season because it's hard. So that's part of why we do the things we do, because it's so difficult to get the data. From a maternal standpoint, so we started doing a maternal behavior score is what I call it at calving. I don't know, in like 17 or 18. We get chased a lot, sometimes by cows that seem lovely and then they calve and they lose their minds. Sometimes by cows that, you expect are going to put you over a fence, and they do put you over a fence. We blacklist really bad ones, but I realized that what we really needed to do is not just to blacklist bad ones, but we needed some indication for next year, what to expect. And so I was sitting in an airport during calving season, going to a grant panel, and I came up with this 1 to 5 system. It's not nearly as, it's squishy. Like in fact, we have descriptors. A 1 is a golden retriever because it's licking you while you're taking stuff from its calf. And a 5 we call a heinous bitch because, she's the one that I tell everyone to stay away from the pen and not even to go up to the outside. And 3 is a normal cow. Well, the problem I found is that what is a normal cow to me is not a normal cow to a lot of people. And I definitely have had some students who score everything way lower than I do and who score everything way higher. But we've looked at that a few times, and in honesty, I'm not convinced that there's a really linear relationship. Some of the worst cows also try to kill their calves immediately. It's a very small population, but some of them also have calves that literally seem to come out with springs. Some of the really chill cows, their calves are real chill because they're real chill and nobody really cares about anything, but they're really maternal and they're always licking them. And, I certainly think that there's a lot of imprinting that happens really early. I've had a lot of daughters of bad cows who, already had decided by like day 2 of age that humans were not to be trusted. And so we've sometimes like blacklisted a heifer calf at birth because we're like, what's the point? But I'll also say that we've got a couple now that we used as heifers in that study that we kept them in the Keeling Gates for like 300 days. And you didn't know, like, I know that their dams are some of the meanest cows I've ever dealt with. They totally were broken because we messed with them so much. And then we sent them away for a couple of years. And when we calved them last year, a couple of them, it's like the instinct clicked in and they turned into their mothers. So yeah, that behavior is really interesting. We don't have enough data on it, to be quite honest. And also those that try to kill us get out of the system, or at least out of my system so quickly that, because my biggest fear is, a student being trampled.
Yep. And I think that's that's a big pet peeve of mine. There is no reason to have a stupid cow.
Yeah.
Like, there are other cows and they're, she raises such a good calf. There are other cows that raise such a good calf and aren't stupid. And so,
yeah, for sure,
and I wonder if there's a correlation between, calf vigor, the ability, their innate ability of that animal, right, to want to get up, to, have that thriving, that thriveability, right,
mm-hmm.
correlates to the docility of the cow and how much that correlates. And maybe.
Yeah. It's something we've talked about a lot, sitting around watching cows calve, and it's, I don't know, it's interesting. It's also interesting to watch how much some really like off calves, and how much, like, we had some of those nutrient restricted females we had lay there for several minutes after. I think they were just tired and they were like, this is really not good. And so that contributed to their calves' lack of vigor and things too. I think probably it's more of that kind of behavior that is worse for calves. There's a lot of data on that in sheep and goats. Because of course, if you have twin or triplet lambs and you don't pay attention to all of them, that's bad. And definitely there's a lot of influence of nutrition. There's also, of course, generally mothering is worse for first parity animals. And so there's a few things that this year I'm going to try to measure, but honestly, I don't expect in cows to pick up a lot of differences in that because, they're cows. But I'll say that it's funny, some of them that you watch and you're like, you laid down, your calf is not up yet and you laid down and you had a quick birth. What is your deal? And there's a lot more variation in that sort of thing than one would expect when they really start to watch them. So yeah, like at one point we were counting vocalizations of cow to calf. That was not very popular because, well, there were a couple of students who thought it was the coolest thing ever. And everybody else was like, oh my God, this is dumb. And so we've generally stopped, but there's been times we've tried to video, but it turns out the cows move around too much. I don't know. There's at some point I'd like to, even though I'm not a behavior person at all, I think it's so fascinating that I would like to look at some of that a little more. But honestly, we probably would just need to put surveillance like calving camera surveillance cameras up to really do it well, because, and honestly, we get in their grills too much. They know we're there. They don't usually care. But sometimes, how many times they're like, oh, were you going to feed me? Like, you were up there by the bunk. Are you going to feed me? And I'm like, no, come on, pull yourself together. You have a baby. But yeah, it's that's probably why I put it in such producery terms, because I would rather be with cows. And we have these conversations always. So sometimes when I talk to scientists, they're looking at me like, okay, dumb cowgirl, could you put this in a science word? Because
no, I need to understand it. Stay where you are.
Yeah, no, I tend to, I don't think I'll ever talk like I don't have shit on my boots, because that's who I am. But anyway, my parents tell me I use too many big words sometimes. So I'm glad that you guys don't think that.
We're good. We're good.
From research background and production background, right?
Mm-hmm.
But there's two things that statistically different and numerically different, right?
Mm-hmm.
People don't understand those two.
Mm-hmm.
And the other one, for when we were talking about this, is that, and I even made it a comment in it, was colostrum replacer versus colostrum supplement, right?
Mm-hmm.
It is two very different things with two very different goals that you're using it for. And you run into that all the time. And they're like, well, numerically, it was numerically different, but if it's not statistically different, it's just a number, right? There's not.
Yeah. Yeah. And I try
to go with those numbers. You know what I mean? Like,
oh, totally. Yeah. And I mean, I personally try to point out some of the ones where I'm like, okay, this is just, we didn't have enough N and I really believe it, but it's so easy to abuse those things and it is hard. But I'll also say on the calf standpoint, if there's, I don't know. I'm not sure if I have, I'm trying to think of what I have. I have something with colostrum replacer versus supplement. Probably it's for class, but if there are some things like that that you all think would be good to get out there in whatever way, whether it's a video or a little blurb write up or something, let me know. Because especially as we're getting into calving seasons again, I mean, you made the comment in here, bottle calves are worth so much. I really do think we've got to push to people that it's kind of crazy at this point to just assume a calf that's going to die has to. And that is I think I can say it in this audience, it's just a very male perspective. And it's also always the cow's fault. And you're like, actually, no, the cow did not want to calve in the, driving snow, but you didn't give her another place. And you're the one that decided when she was going to get bred or that the bull was going to be with her. And
is really winter calving.
Right. Yeah. And fall calving is really summer. So when they just burn up so I think that's when certainly we can manage the cow some, but when people say, oh, I wouldn't want to supplement colostrum, I'm like, but what is that calf worth?
Right.
Come on. And I think now I haven't done the work on it, but I shouldn't say that. I dink around with, there's a lot of calves that come out of data sets, especially like our just big calving data sets, because I decide they're hungry. And so they enter into this, I will manage them how I have decided to, and then I will watch what happens to their blood place. And I think sometimes they even can get by with just milk replacer because they literally just need groceries. And there have been some that like I've let go a few days and I've watched like the fat kind of drain from their little faces. And, then I can like just do very minimal bottling and all of a sudden you see them come back together. And then there does seem to be a point that some of those really thin cows start to make a little more milk or they figure out how to rob. I mean, some of them never really figure it out, but I've had some farm managers I won't name get mad at me about, oh, you can't bottle this calf, they're ruined forever. Absolutely not true, unless their dam is dead or evil or has a terrible udder. I do think that it often can make a lot of difference, and especially I think for small producers that are really being affected that have small enough. Like you can't do that when you have, I was talking to some Brazilians last week that Tiago brought in that, they're dealing with thousands and thousands of acres and thousands of animals. Okay, you can't. But if you have 40 cows, you probably can and want to, have another calf. Even if you sell it when it's a month old, it still is worth money. So
zero.
That is
a higher percentage of that operation versus one calf when you have 2,000.
Yeah.
Cows, right?
Absolutely.
The percentage of your herd or the percentage of your income is affected at a greater number because it is a higher percentage.
Yeah. And I mean, and you fed that cow for a long time. And if we're really honest, a lot of them, especially in a year like this year, are they going to sell a cow if they like her, if she doesn't have a calf at side? Or are they just going to let her get fat? or eat up nutrients like in a year like last year. If you're going to manage her with her cohorts that are lactating, well, they get thin, she gets fat, she may or may not get bred. Now, if you're going to say when the calf dies, I'm going to take the cow to the sale barn immediately, okay. But let's be really honest. Most people are not doing that. And I'm not saying that if somebody wants to move a cow from one season to the next or something, I mean, I'm not saying that I think there's pros and cons for everything, but the thing is that we definitely are not helping ourselves out, and we've already fed them. And in particular, if she's a heifer or if she's a 3-year-old and she loses her calf and it's not her fault. Now, it's one thing if, she ran over it, she beat it to death, whatever. She needs to go away. But if you already put the cost or the development cost into her, if you bought her, God forbid, think of what she's worth right now. And you're just going to say, yeah, well, I let her calf die, so now she's gone too. I mean, luckily she's worth something, but she's not worth what you put into her and you just fed her. And I just don't think, it's not where the cow-calf world is yet, right?
Yeah.
That's where a lot of industries are, but that's not where we are as an industry. And so I'm going to keep beating on this many cows or calves don't have to die pre-weaning until I retire. And then I'm going to hope somebody else takes that over.
That sounds excellent. I really unfortunately have to run because I have to write my presentation for tomorrow. So thank you. Our attendee, yeah, she hopped off after 8, but into a couple questions, and then I think she probably had to go as well.
Mm-hmm. So. Well, I figured it was worth doing it, right? Because if you're going to put it online, I don't think I have this I don't have many of these that are online. I think that's a good resource. So yeah, if you guys want to use it for something else too, feel free if you want to show it or do something else with it.
So in that, when you were talking about the colostrum versus replacer,